Okay, students, so we're here and we're with Triangle, Congruence, Postulates, and Theorems, Phase 1. So if you notice, some of these things we're talking about today are postulates. We just accept them as fact, but others are theorems and we actually prove them to be true. But nonetheless, let's just dive in. All right, so we originally started with needing 6 pieces of information to say triangles are congruent. All 3 angles, all 3 sides. Then we narrowed it down to 5 pieces of information, all 3 sides, but we only needed 2 angles, because if we knew 2 angles were congruent, the third were guaranteed to be congruent by the third angles theorem. Now, we're going to talk about the bare minimum information we need. So I'm here in the iBook, and preferably you can just read the iBook on your own and complete these notes on your own. So if you want to stop the video and just open up your iBook and do the notes that way, that's great. But if you like to hear me talk, then just keep watching these videos and I'll take you through the notes. All right, so we're gonna really boil everything down to just needing 3 pieces of information. And the first one we're gonna talk about is the side congruence postulate. We call it this SSS, that's, all right? So if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. And in fact, in this example over here, notice how it's saying AB is congruent to DE, BC is congruent to EF, AC is congruent to DF. So since all 3 sides are congruent, it actually guarantees the triangles themselves to be congruent. All right, so that's the first one, side. All right, now looking right here, this is huge. We have the reflexive property, all right, allows you to conclude that the side is congruent in both triangles. So let's go ahead and try to draw this picture right here. All right, so this is going to be quite common and we have to be really good at this. All right, so it might say, well, this side and this side are congruent. This side and this side are congruent. So it tells us 2 sides specifically are congruent, but what we have to be really good at is saying, well, what about this shared side right here? This shared side, OMG people, this is actually congruent to itself, all right? This is the reflexive property. And a small typo, that should say page 51, but anyways, all right? So when we see 2 triangles sharing a side, boom, we know that side's congruent to itself by the reflexive property. All right, so we got this yellow box right here. Again, you can try these problems on your own, but is there enough to say that these triangles are congruent by SSS? This first one is yes. Why? Congruent. And then we have this third side that's congruent, so we have a side, and a side. So yes. Oh, what happened there? Yes, check answer, yippee. All right, now here, although we can say, boom, we have a side, but we have a big question mark here. It never tells us that these 2 sides are congruent, and there's nothing that we can use to determine that they are. So right now the answer is no. Here, this is a clear yes. You can't see why this is yes. I feel sorry for you. All right, now this is saying what additional information do I need to prove that these triangles are congruent side. All right, so it's not EC is congruent to CE. That's not the answer. Why? Because we know that's congruent. And I have a side, but what I need to know is I need to know that DC is congruent to GC. This is what I need to know. Because if I know these 2 sides are congruent, then I know all 3 sides are congruent. So boom, that's the answer right there. Nice. All right, and then we're still doing the same thing. We're looking for side. So we're given, ooh, I like this one a lot. All right, we're given AB is congruent to DE. So ABDE. This unit, it's incredibly important for us to draw in our pictures. Why? Because we also say CE is the midpoint of AE. So C is the midpoint of AE. Midpoint, well, we've used this a lot. We haven't talked about it in a little bit, but that's going to force AC to be congruent to CE. That's what midpoints do, if you can recall. So really what we just need is BC and CD. Oh, interesting how it said. It says, so I can specifically say BC is congruent to CD, or this one, I like this problem, kind of like amping it up a step. If C is the midpoint of DB, that would also guarantee it to be, did I read that wrong? I think there's definitely a typo in here, because that would work. Anywho, I have to go contact someone about that. Whoever made this iBook had a, what is it going to say? None of these? No. C being the midpoint would definitely help. Whoever made this iBook had a brain fart. Shame on them. Anywho, hopefully that's the last brain fart. And then this problem right here, I like a lot. All right. ABC has sides 6, 8, and X. All right. DEF has sides 6, 9, and X minus 1. All right. Find all possible values of X. Well, it's the way it works out. AB and DE have to be congruent. All right. AC and DE have to be congruent. So that means X is 9, and that works out perfectly, because if you plug in 9 here, boom, you get that to be congruent. If you plug in 9 here, spits out, oh, that's weird how I wrote it, but plug in 9 here, and it spits out 8, and those two sides will be congruent. All right, and then over here, ooh, this one looks like a doozy. Find all possible values of X. So again, this is kind of quirky how it organizes it. The 25s, let's match those up. I'm going to call these ones the 25s. All right. Now, obviously, then we have 19. Which one matches up to 19? It can't be 28. I'm going to match up 19 and 4 minus y. So then that leaves 28 and 5x minus 2. So it says find all possible values of x. Well, you just set them equal to each other, because we're doing side, side, side. So then 30 equals 5x, or x equals a famous number 6. All right, so that's it for side, side, side. We'll progress in the iBook. Again, you can work without watching the videos, but we're going to do angle, side, angle next.